Hello everyone. Today we are going to again go with this chapter acid, bases and salt. This is the third video and we are going to start on bases. So our topic is about base, and bases are usually metallic oxides, metallic hydroxides or ammonium hydroxides that reacts with the hydronium part of the acid to produce salt and water. So what I told you, it is metallic oxide or metallic hydroxide or ammonium hydroxide. So if I take examples like copper oxide, if I take example of sodium hydroxide, if I take examples of calcium hydroxides, so you can see student, they are all bases. So this metallic oxide, metallic hydroxide and ammonium hydroxide, they react with the hydronium part of the acid to produce salt and water only. Here the word only has got much importance. I am going to show you here. Like copper oxide, when I treat with HCl, it forms or dilute HCl, it produces CuCl2 and H2O. So salt and water. So here you see PbO is a base. PbO is a base. Why? Because it reacts with HCl dilute form to form PbCl2 and H2O. So here we call this PbO is a base. But when we go with PbO2 and treat with HCl, it is going to produce PbCl2 plus 2H2O plus Cl2. So it is not a base. It's not a base. It's not a base. Why? Because apart from salt and water, it is also going to produce something apart from that. So if it is producing apart from salt and water, you cannot consider it to be a base. So PbO is a base, but PbO2 is not a base. Student, you can see all these metallic oxides or hydroxides. If I take sodium hydroxide, it reacts with the hydrochloric acid to produce NaCl and H2O. So they are forming salt and water, and this is what we call as a neutralization reaction. So this neutralization reaction, whoever can show it with the acids will be termed as a base. But be sure that it is producing only salt and water. Apart from that, nothing else. Otherwise, we cannot call them a base. Now, we have to distinguish between a base and an alkali. The bases which are soluble in water, if I remove all these to make the board clear, we will see that the bases, BASES bases, upon this basis, if I take it as a set, and alkali is a subset. Alkali is a subset of this base. Why? Only alkalis are the bases, BASES bases, which are soluble, SOLUBL, soluble in water. Like examples are NaOH, KOH, CaOH whole twice, and you can say NH4OH. All these are alkalis because they are soluble in water. So bases which are soluble in water are called as alkalis. So all alkalis are bases, but all bases are not alkalis. Like if I take examples with copper hydroxide, if I take FeOH whole thrice, if I take PbOH whole twice, these are not soluble. These are not soluble, SOLUBL, soluble in water. So these are bases but not alkalis. These are bases but not alkalis. So all alkalis are bases but all bases are not alkalis. Then you have to write this definition that alkalis are the bases which are soluble in water. An example is this. And some bases like copper hydroxide, iron hydroxide, lead hydroxide, they are not soluble in water and are not alkalis. So they are not alkalis. So all alkalis are bases but all bases are not alkalis. This is all you have to keep in your mind. Our next thing is to know about the acidity of the base. So the bases, particularly the alkalis, when you are dissolving in water, when one molecule, please write it down about the acidity of the base. I will just make you to, I will give you time for writing it. Take out your copy and you start writing acidity of a base. It denotes as the number of hydroxyl ions are being produced by one molecule of base when it is added to water. So when one molecule of base or alkalis is added to water, it is going to produce hydroxyl ion. The number of hydroxyl ions that can be formed by one molecule of acid on its hydration is called as the acidity of the base. In knowing the acidity of the base, we can have NaOH, whose acidity of base is 1. Acidity of base is 1. Of calcium hydroxide, the acidity of the base is 2, and aluminum hydroxide, the acidity of the base is 3. So usually we go with 1, 2 or 3. You cannot get here 4. So NaOH with 1 OH, when you are adding in water, it dissociates into OH minus ion, only 1 OH minus ion from one molecule of that alkali. Calcium hydroxide also similarly, it disintegrates, it breaks upon with 2 hydroxyl ions, so 2 and aluminum hydroxide with 3. Our next part is to know about the bases which are strong and weak. Bases are again classified in 2 ways. One is called strong base, and the other is weak base. In strong base, we have lithium hydroxide, LiOH. We have sodium hydroxide, we have potassium hydroxide, we have calcium hydroxide, we have strontium hydroxide, and we have barium hydroxide. So these are strong bases. Why I call them as strong is that when you are adding them in water, they completely or almost completely breaks up into ions. They almost completely dissociates into ions. So in water, so lithium hydroxide, so 6 strong bases we have in the market. 1, 2, 3, 4, 5 and 6. So 6 different strong bases you have to keep in your mind. And weak base, the rest of all are weak bases like copper hydroxide, like iron hydroxide, ferric hydroxide, lead hydroxide, zinc hydroxide. The rest all will be the weak bases. So who are the weak bases? The weak bases are those which dissociate partially in water. Here we have for the preparation of bases. As many as 7 to 8 preparations we are going to do it today. It will be so handy. It is so easy also. You can see from metals. First point about metals. Any metals which are found above the hydrogen in the activity series, they react with oxygen to produce the corresponding oxides. So you can see calcium and sodium in the presence of oxygen, they form the metallic oxides. Which are found below hydrogen, you have to give a good amount of heat and pressure to turn them into their oxides. Now let us go for the next part, the reaction between the reactive metals and water. Sodium or calcium, potassium, they react with water. Remember, if you take sodium and potassium, cold water will work, and if you take calcium, hot water or warm water will do the best. Otherwise, if you take hot or very warm water, in case of sodium, it will be violent in reaction. So it is going to produce sodium hydroxide and hydrogen, and calcium hydroxide and hydrogen. And remember, this calcium hydroxide is highly soluble in water. Sodium hydroxide is also highly soluble in water. So you are going to form their bases. This should be alkalis, and the reaction of the reactive metallic oxides in water, the oxides reacts with the water to produce the corresponding alkalis, sodium hydroxide and calcium hydroxide. By the double displacement method, this you have already done in analytical chemistry, that with sodium hydroxide or ammonium hydroxide, you can make the corresponding hydroxide from the salts. So student, you can see how we are going to turn the salt back into bases. Once we have shown in the preparation of the bases, bases that they react with the acid to produce salt and water, and again from the salt, again they react with the bases to produce another more base, that is non-hydrolysable part. Here this is not soluble in water. So sodium hydroxide is soluble, sodium hydroxide is soluble, ammonium hydroxide is soluble, but it is producing an insoluble basis. So if you are going to turn the soluble base into insoluble base, this is very important. In your exam, they may give you to cite some examples where the soluble base turns into insoluble bases. So student, here we have one more for this reaction with oxygen with metallic sulfides like iron sulfide, zinc sulfide, lead sulfide. This, in the presence of oxygen, they forms the corresponding oxides with the liberation of sulfur dioxide. This reaction is usually called as roasting. It's called roasting. So heating in the presence of, you have to give a huge temperature. So when you heat it at a very high temperature in the presence of oxygen, this is what we call roasting, and it forms a corresponding oxide, metallic oxide, together with the liberation of sulfur dioxide. So student, here we have the next part is about the salt decomposition. Some salt like calcium carbonate and lead carbonates and nitrates. I have taken examples with calcium carbonate and nitrates. When you heat it, this is what we call it as calcination. This is called roasting and heating in the presence of oxygen. This is heating in the absence of oxygen. So we call this as calcination. C-A-L-C-I-N-A-T-I-O-N, calcination. And when you heat it, it forms the corresponding oxides and carbon dioxide. Here it produces lead oxide, and it produces nitrogen dioxide, and also produce oxygen. So student, here you can see nitrogen 4, NO2 and O2. So here you see this lead nitrate, it is a colorless material, it's a colorless crystalline salt. Here PbO is yellow colored, nitrogen dioxide, it is yellowish brown, and it's forming a brown gas, and oxygen again is being formed, which catches fire when you bring a burning splinter near to it. Reaction between sodium carbonate and slaked lime. Sodium carbonate and slaked lime, it is going to produce sodium hydroxide and calcium carbonate. Here this process we are using it in getting slaked lime. We are going to use slaked lime to get sodium hydroxide. There is another more process is about adding ammonia in water. When you add ammonia in water, this may be the 8 point. This ammonia in water, it is going to form ammonium hydroxide, NH4OH. So in this way, these are the 8 different processes by which we can prepare bases.